student, we start exercise 6.5, sum number 23. In 23, prove that, just a minute. In 23, we prove that the volume of the largest cone that can be inscribed in a sphere of radius capital R is 8 by 27 of the volume of this sphere. Okay, this is our statement of 23. Now we draw the diagram and let R be the radius of the sphere, capital R be the radius of the sphere, and small r be the radius of the cone. Okay, then we go through figure. Okay, now we start it. Here, according to the diagram, let R be the radius of the sphere and small r be the radius of the cone. Therefore, the height PM of the cone is equal to R, and we let that this OM be X. Then we get X equal to R plus X. Now we want to find the volume of the cone. So volume of cone is equal to V, which is pi R square H, right? And H equal to R plus X. So we just put the values, and R square is R pi. Here we place the value of R square, which is R square minus X square, and this is R plus X. Now we just simplify it, then we get the function of X, Fx pi R cube minus X square R cube minus X square R plus X R square minus X cube. So this is our one equation which we can obtain from the given here. This is 1 by 3. Cone is 1 by 3. So pi by 3. So cone, volume of the cone is 1 by 3 pi R square H. And here we just simplify it, then we get pi. This is our first answer. Now we find first derivative. Then first derivative is equal to what? Pi by 3 minus 2xr plus r square minus 3x square. Again we derivate second time, f double dash x. Then we have pi by 3 minus 2r minus 6x. Right? Now we take this first is 0, f dash x is 0, and we just find the value of anyone, x or r. Okay, then this becomes 0. It means we have the factor of this is x plus r, and 3x minus r equal to 0. And we want to just find the value of x is minus r, which is not possible because r is always positive, or x equal to r by 3. This is the value which we can put into. We get f double dash r by 3 is equal to pi by 3 minus 2r minus 2r. It is minus 4r pi by 3 less than 0. Therefore, at x equal to r by 3, we get maximum volume of cone. Okay, now the volume of cone is, or we find the relation between x and r. Now we use this relation to find the or to prove our result. Now we just put this volume equation, put x equal to r by 3 in v is equal to 1 by 3 pi r square h, or it is pi by 3 r square minus x square into r plus x. Okay, here just we put the value of x, which is r by 3. So we have pi by 3 r square minus r square by 3 into r plus r square by 9, not 3, but r square by 9, and r plus r by 3. So we have pi by 3, 8r square by 9 into 4r upon 3. So it is 4 by 3 pi r cube, 4 by 3 pi r cube, and what is that? Into 8 by 27. Okay, so we can say that is equal to 8 by 27 and volume of sphere. Okay, and we want to just prove that that the volume of the cone is 8 by 7 times the volume of this sphere. So this way we can obtain our answer. Here you just, yes, sorry for the interruption, but here this is good sum, and again we just recap. Okay, here capital R be the radius of this sphere and small r be the radius of the cone. Okay, height is equal to r plus x. Here we let this assume that x. So here x equal to r plus x and r square equal to r square minus x square. Now volume of cone is V, which is 1 by 3 pi r square h. Here we put the value of r and h, simplify first derivative, second derivative, first derivative is 0, then we obtain the answer x equal to r by 3. Now this r by 3 we put in f double dash, then we get less than 0, means the volume is maximum when x equal to r by 3. So now this r by 3 we put in the equation of volume of the cone. Okay, and just simplify, 8 by 27 is outside, and here 4 by 3 pi r cube is there, which is the volume of the sphere. So we can say that 8 by 27 times the volume of the sphere is equal to the volume of cone. Okay, next. And this sum is very important for your board examination, so be careful and do it 4 or 5 times. Now we go for the next. Okay, next sum, 24th. In 24th sum, show that the right circular cone of least curve surface and given volume has an altitude equal to root 2 times the radius of the base. So first of all, remember that what we want to be proved. Okay, and it is very important for us. So first of all, we assume that V be the given volume of the cone, and let small r be the radius, h be the height, and capital S be the surface area of the cone. First we draw the diagram and then we go for the next one. Proceed on. Okay, so according to the diagram, height of the cone is h, base radius is equal to r, and volume is b. And we know that V is equal to 1 by 3 pi r square h, and curve surface area is equal to pi r under root x square plus r square. L is equal to root x square plus r square. And here, if we find from the volume h is equal to 3v upon pi r square. Okay, so 3v upon pi r square is the h. Now here s square is equal to pi square r square under root x square plus r square. Now here we just place the value of this h and we find our first answer, and this is the function of r. So fr is equal to pi square r square we put as it is, x square is equal to 9v square upon pi square r raised to 4. Now we just multiply this pi square r square in bracket, then we get pi square r raised to 4 plus pi square is removed, r square, 9v square upon r square is left. Okay, this is our function. Now we derivate first time, f dash r is equal to 4 pi square r cube minus 18 v square upon r cube. Right? Then again we derivate f double dash is equal to 12 pi square r square minus or plus, this is plus, cube 54 v square upon r raised to 4. Okay, so this way we just find the first value. Okay, then this is always greater than 0. Now we put f dash r is equal to 0. So what we have, therefore 4 pi square r square is equal to 18v square upon r cube. Right? Now we want to find r cube. This is r cube. Now r cube we put here. So we get r raised to 6 is equal to 18v square upon 4 pi square. It is 9v square by 2 pi square, or r is equal to 9v square upon 2 pi square raised to 1 by 6. This is our first equation, which is very helpful to find the next answer. Okay. So we can say that for r equal to 9v square upon 2 pi square it raised to 1 by 6, f double dash r is greater than 0 and s is minimum at r equal to the given. Now we put the value of means here r raised to 6 is what? 9v square upon 2 pi square. Now here we put the value of v from here 1 by 3 pi r square x square, pi r square x. So 9 upon 2 pi square into 1 by 9 pi square r raised to 4 x square. Okay, this is our first result. Now here 9 cancel, pi square r cancel, 2 is also cancel. So therefore we have pi square and okay, sorry, not here. So r raised to 6 is equal to just r raised to 4 x square upon 2 is left. Now here r raised to 4 is also cancelled. So r square is equal to x square by 2, or we can say that x square equal to 2r square, or h is equal to root 2r, which we want to be proved. That height of the cone is root 2 times the radius of the base of the cone. Okay? So this is our answer, and this is very easily we obtain. But here the technical point is that first we recap it. First you know that the volume of the cone is 1 by 3 pi r square h, and then s is equal to the surface area. It is pi r l, but l is root h square plus r square, and here from here we find the value of h, which is 3b upon pi r square. Now what? Here we take the square because root is there and there is some difficulties to find the derivative of root. Therefore we take the square both the side and we can. Okay, so h square equal to pi square r square into h square plus r square. Here we put the value of h square here. 9v square upon pi square r raised to 4. Simplify. First derivative, second derivative. First derivative becomes 0. Then we find r raised to 6 equal to 9v square upon 2 pi square. So at r equal to this value, the f double dash r value is always greater than 0. So we can say that at r equal to the something value is s is minimum at r equal to dash. Now we have r raised to 6 is equal to 9v square upon 2 pi square. Now we do not want to this v, so we put the volume's value here and then simplify. Then we simply get h equal to root 2r. Okay, so good sum is there. Remember this thing very carefully, that this sum is very good and most IMP for board. Okay, next. Okay, next 25, not 24. Show that the semi-vertical angle of the cone of the maximum volume and of given slant height is tan inverse root 2. So here first cone is given and we want to just find the given that slant height of the cone be L. Let h be the height of the cone and r be the radius of the cone and alpha be the semi-vertical angle of the cone. These all things we derive and then we write and then we explain it. Okay, now here L be the slant height of the cone, h be the height of the cone and r be the radius of the base of the cone and alpha be the semi-vertical angle of the cone. Okay, now from this figure we can say that r equal to under root L square minus h square. And we know that the volume of the cone is 1 by 3 pi r square h. Here we place the value of r square, which is L square minus h square, right? And then we get v equal to pi by 3 h L square minus h cube. Now what? This is a function of h. Therefore we can say that fh equal to pi by 3 h L square minus h cube. Now we derivate first time and second time, we get f dash h is equal to pi by 3 h square minus 3 h square. And same thing, that f double dash h is equal to pi by 3 into minus 6h, or we can say that minus 2 pi h, which is always less than 0. Therefore, or first we find f dash h is equal to 0. It means L minus root 3h, L plus root 3h will be 0. Now here, this is not acceptable because here the value of L or h be negative. So here only the accepted value is L minus root 3h equal to 0. So therefore, L is equal to root 3h or h equal to L upon root 3. Now this h is equal to L upon root 3 is obtained, and h equal to L by root 3, f double dash L upon root 3 would be less than 0. Therefore, h equal to L by root 3, f h get maximum value. Okay, now up to here you know. Now h equal to L upon root 3 and we want to just find tan alpha. Okay, so what we do, first of all we get h equal to L by root 3, and here we, according to the diagram, this is right angle, so therefore from figure, tan alpha is equal to r upon h, or sorry, opposite upon adjacent, r by h. Okay, r by h. Now what? Here r is equal to, given that root L square minus h square, so it is under root L square minus h square upon h. Now we just place the value of h equal to L upon root 3. Therefore tan alpha is equal to root L square minus L square by 3 upon L upon root 3. It is under root 2 L square upon 3 upon L by root 3. So the root 3 and root 3 are cancelled. Therefore, tan alpha is equal to root 2 L upon L. L is also cancelled. Therefore, alpha is equal to tan inverse root 2. So this way we can obtain our semi-vertical angle alpha is equal to tan inverse root 2 of cone, right? So this sum is also very important sum, and again we just explain it, so we get our or you clear the answer that cone is given, and here L be the slant height, R be the radius of the base, and H be the height of the cone. Okay, alpha be the semi-vertical angle of the cone. Now here first of all, R is equal to what? According to the diagram, R is equal to under root L square minus h square, and volume of the sphere, volume of the cone, you know very well that V equal to 1 by 3 pi r square h. Here you put the value of R. R is root L square minus h square, but here root is cancelled. So 1 by 3 pi h L square minus h square. Now what? We just simplify, and here pi by 3 bracket h L square minus h cube is there. Now we take, this is a function of x, therefore fh is equal to pi by 3 h L square minus h cube. Now we take the first derivative. First derivative is pi by 3 L square minus 3h square. Okay. And f double dash h is equal to minus 2 pi h, which is always less than 0. So we can say that hf dash h equal to 0, we get the minimum value of f double dash or fh. So f dash h equal to 0, L minus root 3h, L plus root 3h equal to 0. This term is not acceptable because height and slant height both are positive value, and here we obtain it is negative, so it is not acceptable. Only this will be acceptable, and here L equal to root 3h and h equal to L by root 3. So at h equal to L by root 3, f double dash L by root 3 is less than 0, and we can say that at this fh get maximum volume or value, and it means what? The volume is maximum at h equal to L by root 3. Now from this figure, this is the right angle. So here tan alpha is equal to opposite upon adjacent. Opposite upon adjacent is r upon h. R is not given, but here the value of r is there, root L square minus h square. So we just put this value and we put h equal to L upon root 3 here, and then simplify. We get tan alpha equal to root 2 and alpha equal to tan inverse root 2. So this way we can find our answer. So this sum is also very important sum. In this lecture we just take only three sum, but these three sums are very important for your board examination. So be careful for these three sums, and these three sums are most IMP sum for the board's exam. Okay, then we go for the next topic or next lecture. Okay, thank you.